Welcome to the session on addressing modes of 8051 microcontroller. The various ways of specifying data are called as addressing mode. It means that when you specify data in the instruction, in what way it is specified, that decides the addressing mode of that instruction. These are the different types of addressing modes of 8051 microcontroller. First one is register addressing mode, second one is immediate addressing mode, third one is direct addressing mode, fourth one is indirect addressing mode, and fifth one is index addressing mode. Out of these five modes, last three modes, that is direct addressing mode, indirect addressing mode, and index addressing mode, are related to memory. It means that data is stored in memory. Now let us move to the first mode, that is register addressing mode. The operands, that is source and destination, are located in register. And in 8051, the register can be R0 to R7 register, it can be accumulator, it can be register B, or it can be data pointer, that is DPTR. Let us take one example. Here the instruction is move A, R5. The source operand is R5. The destination is accumulator, that is register A. After execution of this instruction, whatever is the value that is stored in R5 register moves to the accumulator. Say R5 is having 25. Then after execution of this instruction, that 25 will get copied in accumulator. Let us take one more example. Increment DPTR. This is an arithmetic instruction. Here the number stored in DPTR is incremented by 1. DPTR is a 16-bit register which points to the data memory, and that value gets incremented by 1. Say 1000 number is stored in DPTR, and when this instruction is executed, this 1000 gets incremented by 1, and the new value, which is 1001, will be stored in DPTR itself. So the value is not mentioned in the instruction, but it is mentioned in the form of register, and that's why this addressing mode is called as a register addressing mode. The length of this instruction is 1 byte. What is the meaning of the length of instruction? It means that when you write the program and when you store that program in program memory, this instruction will require 1 byte of memory to store its opcode. So that's why the length of instruction is 1 byte. Move R1, R5. This is a sample instruction given. It is an invalid instruction. Means even if R1 is a register, R5 is also a register, but this instruction is invalid in 8051 because we cannot move data from one register in a bank to another register by using register addressing mode. So this is all about first addressing mode, that is register addressing mode. Let us move to the second addressing mode. It is immediate addressing mode. The source operand is immediate number. It is an immediate number. So what does it mean? It means that the number which is to be moved at destination is mentioned in the instruction itself. Here you will see that move A, hash 27h is written. So the number is preceded by hash symbol. The immediate number is specified in the instruction and hash symbol is mentioned, and that hash symbol indicates that the number itself is to be moved in accumulator. So 27 is moved into accumulator as it is. There is one more example where move dptr hash 1000h is mentioned. Here you will find that the source operand is 16-bit number. It is 16-bit number because in hexadecimal 4 digits correspond to 16 bits in binary, and it moves the number 1000h into DPTR. So DPTR will be now 1000h. So the number which is to be moved is mentioned in the instruction itself. Now I have used the term number, I have not used the term data, because this number can be used as a data as well as it can be used as a memory address. That depends on after this instruction what instruction we write. For time being, remember that the hash means immediate number. So this is immediate way of mentioning the address. Move hash 25h comma R5, it is an invalid instruction. Why it is invalid instruction? Because you cannot have immediate address at destination. How you can move one number into another number? You can move a number into register, you can move a number into memory location, but you cannot move a number in number. That's why hash return at destination is an invalid instruction. We cannot write such type of instruction. The third type of addressing mode is direct addressing mode, and this addressing mode is related to memory related operation. This is related to memory related. It means that data is stored in memory and the direct address of the operand is specified in the instruction. What do you mean by address? Address means it is the place where a data is stored. Say this is the memory where the number 45H is stored. This 45H will certainly have some address and say 30H is the address. So in this type of addressing mode, the data is not mentioned, but the place where data is stored, that address is mentioned, means 30 is mentioned. Let us discuss it. We can access the 128 bytes of internal RAM because 8051 has 128 bytes of internal RAM. The starting address of internal RAM is 00H. The ending address is 7FF. So 128 bytes of internal RAM or SFRs can be directly specified by 8-bit address. So when we write any of this address in the instruction, that obviously we are using the direct addressing mode. Let us take the example of direct addressing mode. Here the instruction written is move a comma 45h. Now remember here that no hash symbol is written. No hash symbol is written. So what does it mean? It means that 45 is the address of memory location. 45h is the address of memory location, and what we are doing, we are moving the content of memory location having address 45h to accumulator. It means that some value is stored in memory location 45h and that value will be moved into accumulator, or that value will be copied into accumulator. 45 will not be copied in accumulator. Let us take the example. Let us assume that before the execution of this instruction, the 45H location of internal RAM has 15H value stored inside it. So this is the value stored in 45 location and accumulator have some value. When we execute this instruction, then after execution of this instruction, the value stored in 45H, that is 15H, is copied into accumulator. So this 15H gets copied into accumulator, means whatever was the earlier value in accumulator, that gets overwritten and the new value in accumulator is 15H. 45H is not moved in accumulator. Remember that this is different from the immediate addressing mode. And in order to view this, let us go to the kill software and let us say that I have written the instruction like this: move a comma hash 45H. So what does it mean? It means that move the number 45H into accumulator, because I have put hash symbol, and that is the example of immediate addressing mode. Now let us build the target. The first step to run the program is start stop debug session, and after execution what is expected? This 45H value should be copied into accumulator. Currently there is 0 in accumulator. Now I will run the program. Now let us run the program, and you can view here that the content of accumulator have become 45H. It means that the number mentioned in the instruction is moved into accumulator. The common mistake which is done by the programmer is that if they forget to write hash symbol before the number, then still it is a valid instruction. Just we have seen the example of direct addressing mode. This is a valid instruction. But what will it do? It will not move 45H to accumulator, but it will move the number stored in internal RAM location having address 45H in accumulator. Now let us practically verify it. So debug, start stop debug session. Now for that purpose, I have to go to the internal RAM. Let us type the address of internal RAM as 45H, and before execution, let us load the value 99H in internal RAM. I have still not run the program. Now content of accumulator are 00. Now what will be moved in accumulator? Whether 45 will be moved or the number stored in 45, that is 99 will be moved. Let us see. Debug, run the program. Now you can view here that accumulator has become 99H. It means that the number stored in memory address 45H is moved into accumulator. What is stored in 45H? 99 is stored. So that 99 is moved into accumulator. So this is the example of direct addressing mode. The fourth type of addressing mode is indirect addressing mode. It is indirect addressing mode, and other name to indirect addressing mode is register indirect addressing mode. Indirect addressing mode is also called as register indirect addressing mode. In this addressing mode, the register is used as a memory pointer. This is a new concept. Memory pointer means it points to the memory address. It points to the memory location. The register holds the address of memory location. Means which memory location we want to access, address of that memory location is stored in register, and that register is mentioned in the instruction. Address is not mentioned in the instruction. For 8-bit addresses, means if you want to deal with internal RAM, then registers R0 or R1 of currently selected register bank, because R0, R1 exist in all 4 register bank, but currently register selected bank which is having R0, R1, those two registers are only allowed to be used as memory pointers. You cannot use R2, R3, R4, R5, R6 or R7 register as a memory pointer. Remember this, only R0 or R1 registers are allowed to be used as a memory pointer. If you are using 16-bit address, means if you are using data memory, in that case 16-bit register is to be used, and DPTR, which stands for data pointer, it is a 16-bit register which can be used as a memory pointer. In short, for internal RAM, R0 and R1 are used as a memory pointer register, and for data memory, 16-bit register, that is DPTR, it is used as a memory pointer to access the data. And one way of remembering the register addressing mode, one way of remembering indirect addressing mode or register indirect addressing mode is that use of @ symbol. This @ symbol is written before R0 or R1, or @ symbol is written before DPTR. It means that memory pointer name is always begins with the @ symbol, and whenever you come across @ symbol, definitely you can predict that this is the example of indirect addressing mode. Let us take one example of indirect addressing mode. Here the instruction given is move a comma at R0. Now what does it do? This instruction will move the content of RAM location. It will definitely move the data inside a RAM. Where it will move? To accumulator. But what about the address of data? So it will move the content of RAM location whose address is held by R0. It means that the content of memory location is to be moved, but the address of memory location is in R0, and that R0 will point to the data. That's why it is called as a memory pointer. Let us take one example. Say R0 is having address 40H. The number stored in R0 is 40H. Accumulator is holding some value, and assume that 40H internal memory location has 89H of data stored inside it. The data stored is 89H. Now what I want to do? I want to move this 89 into accumulator. I want to move 89 in accumulator. If I had to use the direct addressing mode, if I have to use the direct addressing mode, then I would have written move a comma 40H. So it would have done the same thing. It would have moved the content of 40H, that is accumulate 89 into accumulator. But the same thing can be done by another way. And which is that way? By using the indirect addressing. How it is done? First, load the memory pointer with the desired memory location address. Here R0 is loaded with 40H, and then write the instruction move a comma at the rate R0. What will it do? It will look for the value in R0. What is the value in R0? It is memory location 40H. So address of memory location is in R0, and then it will move the content of 40H. What is content of 40H? It is 89 into accumulator. So in short, I can say that it moves content of RAM location whose address is held by R0. So after execution, this 89H is moved into accumulator. So this is the way of moving the content of memory in accumulator. Now the question arises, if you are having the direct addressing mode, means if the same thing can be done by writing this instruction move a comma 40H, then why to go for such complicated method? Why to go for such complicated method? It has its own advantages. Indirect addressing mode has its own advantages, that when you want to deal with continuous memory location and when you want to execute a particular program in a loop, in that case, indirect addressing mode reduces the length of the program. Indirect addressing mode reduces the length of the program. Program becomes very simple as compared to use of direct addressing mode. So when you want to access the memory location dynamically, or when you want to deal with number of memory locations and you want to access them in a loop one by one, in that case prefer the indirect addressing mode. And the last addressing mode is index addressing mode. Here definitely we are going to access the memory. Particularly this mode is used to access the data stored in program memory. Remember this, indexed addressing mode always uses program memory. Now what is the meaning of index? The address of program memory is calculated by taking the sum of two registers. First one is a base register, which generally points to the starting address of lookup table, and second register is an index register, which points to the how far that data is located from the base address. So addition of base address and index address will give you a certain address, effective address, and content of that memory location is moved. Now which registers can be used as a base address register? Program counter and DPTR. These two registers are allowed to be used as base registers. And what about index register? Register A, that is accumulator, can be used as an index register. This method is used to read the lookup table entries. This particular method is suitable to read the content stored in a lookup table. There are continuous memory location in program memory, and you have to search one of the data from those entries. In that case, this addressing mode is used. Let us take one example. There are two MOVC instruction. First one is MOVC A comma at the rate A plus DPTR, and the second instruction is MOVC A comma at the rate A plus PC. We will take the example of first instruction, that is MOVC A comma at A plus DPTR. As told earlier, DPTR is used as a base register. So DPTR will definitely have some value. Accumulator is an index register, so it will have some value in it. First of all, what will be done? The sum of these two will be taken. Let us assume that DPTR is holding the value 1000H and accumulator is holding the value 05H. So what will be done? A plus DPTR will be will be calculated. So what is A plus DPTR? 05 plus 1000. It comes to be 1005. And this at symbol indicates that this data is to be not moved, means 1005 is not to be copied in accumulator, but the content of 1005 are to be copied. So whatever is the data that is stored in 1005, here 66 is there, that is to be moved in accumulator. So after execution, the content of accumulator will become 66. Originally it was the index register, accumulator was pointing to the 05. But after execution of this instruction, in lookup table, the content of 1005 will be moved into A. And in this instruction, you will find that the word C is followed by move. It stands for code memory, and code memory means program memory. So index addressing mode is particularly used to access code memory where there are different lookup table entries. So this is all about the addressing modes of 8051 microcontroller. Thank you.